I'm Michael Pawlyn, I'm an architect, and I have a particular interest in biomimicry. At Exploration Architecture, we use biomimicry to rethink all sorts of building types and develop solutions that use resources much more efficiently. Biomimicry is innovation inspired by nature. It involves looking at how things work in biology and then learning from that to design better solutions. In biology, you often find very complex structures that achieve amazing resource efficiency by putting the material exactly where it needs to be. With computational design and 3D printing, it's getting much easier to mimic that level of complexity and efficiency. In 2014, we were asked to put on an exhibition at the Architecture Foundation. We proposed a whole series of 3D printed tables that would display the projects. It used algorithms to work out what the most efficient place for all those materials would be, based on bone and tree growth patterns. And what we ended up with was something that used 1,000th of the material of a solid object of that volume. Bird skulls are a great example of a complex and very efficient structure. And we used computational design to produce a version of this. We created this 3D printed model, which is an enlarged version of a bird skull, which ultimately we want to turn into a pavilion structure. We were able to model this in a way that was quite similar to the way it actually grows in biology. And what you have is these domes of incredibly thin, bony material connected together with these struts and ties. Overall, it's incredibly lightweight and very structurally efficient. What you can see often in shells and leaves is very thin surfaces turned into strong structures simply by folding them or having curves. That's something that we've done in the abalone house. We're learning from the same principles to turn a thin surface into something that's very strong. We're using tiles made out of atmospheric carbon. And that's what we need to do more of. We need to find ways to make buildings by taking carbon out of the atmosphere. By collaborating across science and art and computational design, it gives us a chance to get much closer to the way things work in biology. Buildings and cities that are zero waste, that use far less material, emit no pollution, we can get to a point where architecture is actually producing a positive impact.